everybody, but this point I did not understand. So how field control the particle?
Yeah. Bohm had the metaphor. The metaphor he used was a ship, because it was a long time ago. There were, so a ship that is guided by radar pulse. You have by radar waves from the shore. Now, why is this metaphor in my eyes is good? Because it says the energy for the movement of the ship is not coming out of the waves. The waves only gives the information where to go. It's not pushing and pulling the ship. When you have electromagnetic waves or other, when they interact with matter, when electromagnetic waves interact with matter, there is a transfer of energy, or from the, for example, if an electron absorbs a photon, gets energy and go to a higher energy level in the, for example, the hydrogen atom. When he emits photon, so there is a transfer of energy and momentum. But it doesn't work, it cannot work in Bohm picture. Why? Because we say that this wave is acting non-locally, immediately. Is connecting. You change the setting of the experiment, and immediately 10 kilometers away.
You mean EPR?
EPR, for example. Okay. Even the two slits experiment, you can show that sometimes you decide to close or open a slit, or to put a detector or not to put in the last minute, and it doesn't mind its influence, the setting of the experiment, even if it was changed too late for a light or anything else to transfer and connect or communicate the particle, and tells him that he has to go like this and not like this, okay, for example. So Bohm thought about it a lot, he and Heidi, about this problem, because if it was in such a wave, it wouldn't work. He said that it is a new kind of a wave that has, he called it an information wave, that like the radar with the ship. We can think about the ship as the particle. The energy for the movement of the particle is not from the radar wave. The radar wave gives it order, if will be no radar wave, the ship will go in an accidental direction and won't get to her target. So he thought of this wave as an information wave, but that is involved with little, if any, kind of transfer of energy. There is no transfer of energy between the wave and the particle, not as happening with an electromagnetic wave that have interactions with matter, as I told you before. So now we said it might be very, very difficult to get a direct indication. An indirect indication we have, but we can explain it other way. It's not the only possibility. It's one of some. But if we want a direct indication for the realization of this wave, it would be very, very hard in one way. It is not Basil Haile, that is was collaborator for many, many years, and is still alive. He is already more than 90, but he told me sometimes, not once, that he thinks that there will be experiments that would be able to find a direct indication for this wave, for the quantum potential.
Okay, let me interact.
Of course.
So you think that this informational wave just clear information without matter and energy?
It's not information in the way that when I talk and tell you, go 20 kilometers to the north and then turn right, I tell you information.
But you
it's not the same.
Energy, because you're moving at least your chest, and so energy, like sound waves.
The wave is not an information wave, but you hear my voice and you know.
And I get the information.
And this is not like this.
Okay.
This wave has the structure of a wave, and the particle can go only on places where it is allowed. The wave has like this plateau, and like this, and like this, and like this. So it can go only from the places where there is a plateau.
Okay.
It cannot cross.
Tell me what the wave means for me. Something is kind of waving or hesitating,
yes, something
like
is waving,
in the ocean. So what is waving?
The same question you can ask about electromagnetic light. What is waving? Because a wave is interference in a medium. Water wave is waving in a water.
The water molecules are waving,
right?
Are
waving like this and not going.
Not going, but they at least are waving. So the we see.
Wave, not voice. Voice waves are waving in air.
Sound.
Okay, the sound waves are going in
the air wave.
But the mystery where light is waving is since the end of the 19th century, because the thought was that there is something like ether that is not that is a Greek word, ether, and that's something that has no smell, no weight, nothing, that all the cosmos is in it, and the electromagnetic waves are waving in this. But since 1898, it's called two American
I remember they did experiments, so they say there is no ether option.
No, they hypothesize that there is ether, and they put two rays of laser, and they said if there is ether, there will be interference, and not interference, but one ray will get faster than the other one. And till now, more than 100 years, 150 years, no delay, no both rays
Yeah.
come together. So then Einstein in 1905 said that let's assume that there is no ether. And
Нету. Да, no.
no ether, and light is moving in a certain speed, 300,000 kilometers per second, no matter who is if you are moving or if you are standing. Now, nobody can say today what is waving in the electromagnetic wave. So it's the same problem. I don't say that we have a good, like you ask me, what is a photon or what is the light?
So
It's-
this comes to question, what is that? Is it isn't it the interpretation of quantum mechanics should answer on this question? Interpret that in some way.
What we can say now is that a light is a package of energy that sometimes seem to influence, to go forward like a wave. In what it is waving,
Energy is waving or not?
energy, it depends. If it's electromagnetic energy, it's waving. It's electromagnetic wave. When I have a telephone and I'm phoning, electromagnetic wave is going in the space. But I cannot answer, and not only me, no scientist can answer in what way it is waving, but it's behaving like a wave. Even in the vacuum, and there is no ether. That's I can't say for sure because nothing in science is for 100%. Sometimes people come back to things that they throw away because they were not. I can tell you that Bohm proposal is suggesting that there is an ether, or something like that, that there is something that quantum potential, the quantum wave is waving in it. But there is no actual experiment that may
Make it prove it.
yeah. The man that we saw in the little movie I put it called Valentini, he tries to find such proofs that this quantum potential is something real. He tries to see.
I also didn't understand what is quantum potential. So I remember the movie which
Yeah.
you shown.
Every wave or every wave is a gradient of a potential. For example, the electromagnetic wave is a gradient of the electric potential phi. That is not a field. The electromagnetic wave is a field. It's something that has a direction and it's a gradient. But when you take the gradient of electric potential, you get the electric field, E. And in the same way, Q, that's the letter that Bohm took for the quantum potential. If you make a gradient of it, you get a field, a quantum field, that in his interpretation is a guiding wave. Now, what's interesting in Bohm interpretation is that he didn't change at all the mathematical structure of quantum mechanics. He took Schrödinger equation, as everybody that is in this field knows it, and it gave it another meaning. He made a little manipulation, mathematical manipulation on Schrödinger equation. He separated it to two equations, one real and one imaginary, because it's dealing with imaginary field. Psi is an imaginary field. It's not a real field. You know, the complex numbers and all this. And he separated it to two equations. One is composed from the real part of psi, and the second is composed of the imaginary. And he showed, and he didn't change at all. He didn't add something. He didn't took out something, and he showed that he gets mathematical expressions that he gave them meaning. He said, oh, this thing, I can refer to it as a quantum field. And he showed that this field, mathematically, his influence is not getting down by distance. We are not used to something like this. We know that electromagnetic fields, when you go from here twice, is getting down four times. Yeah? It's one divided by the distance square. So, and here he showed a mathematical structure, and he said we can see that this structure is intensity is not getting down when you go even far away. So maybe it's something in the world. Most of the people looked at the mathematics as only science for how to work, how to compute, and didn't think about it. And maybe there's something in the world. And he said maybe it's something in the world, and he said I will call this quantum potential, and we'll see what is behavior. Maybe it makes sense. And the simulations that we saw in the movie about Bohm was that they took this mathematical structure. They took computers, the first computers that were there, and made simulations with this structure, and showed that it gives trajectories for a lot of trajectories, and very not linear trajectories, not that you go from here to here by a straight line, but something that is very complex. And they say, okay, let's look at it as if it's represents something realistically in reality. And they start to build this picture, and I like it. I think it's, I mean, it doesn't mean that it's 400% what happens, but it gives a very nice description that is not till now refuted by science.
References.
No, refuted is that you show that something is not right, that something is not proper, that you reject something and say no, we have experiments that show that it's not true. Okay, and Bohm himself referred to it skeptically. He said it's a vague picture. I'm sure that later, when physics will get a more advanced, this picture will be seen as only an explicate order for something that is much more deeper. He used a lot the words process, and he thought that in the deep foundations of the origins of the quantum phenomena, we are dealing not with particles and waves, like he suggested, but with only fields. That even what we call now matter will be seen later with when experiment will be more accurate or more good. We will see that even the particle is not a real particle. It is a group of intense fields that seems like a particle.
Okay, but what is field in this case? You know, a field in a field of rye, or in Russian language, field is a very, very many meaning word, but usually it's still with something which is in.
From what the field is composed? That is your question?
Да.
See, I will tell you a story. When you have a vacuum states in physics,
Да.
the predictions predict that in a state of vacuum there is a probability for creating particles out of nothing. And when you take seriously field theory of quantum mechanics, you get that vacuum state in physics has an energy field of very, very high. It's not empty. Even though it's empty of anything we know. I mean, anything we know as matter and anything we know as electromagnetic fields and all kinds of fields. So, and people doesn't know how to deal with it. So they did a very complex mathematical procedure that is called renormalization. People got Feynman and other two got a Nobel Prize for it. But what they did in this procedure was only to ignore these extreme intense fields that nobody knows what is made of, but from the mathematics and the treatment, you see that it is there. And actually, when people produce vacuum states, from time to time, you see that it really creates a short time living particles. So you can ask me from where these particles comes. So one answer is we don't know. Second answer, Bohm thought that vacuum energy or vacuum state is filled with he called it hollow movement. Hollow from the word
Holistic.
H-O-L-O. And he thought that in a way, maybe vacuum state is the basic situation. And out of this state comes fields that look, this is not quantum mechanics, this is quantum field mechanics, and are very radical ideas that he only said them, I mean, he thought about them, he talked about them, but he was not, but that was his thinking, that this hollow movement is a basic entity in the world. It's not something, it's not matter, it's not energy, but out of this can come something, a field, an intense field that you can look at him as a particle. He saw once in the BBC, it's okay that I'm keeping? He saw in the BBC once a program that took him very, very, very much. What was the program? What was it about? It was, he saw a glittering liquid that is very, you know, glittering is very, I didn't say it, I don't remember, but it's a very heavy liquid between two cylinders.
Yeah.
Inside and outside, and the glycerin is here. And he saw in this program that someone is dipping a iod ink in this. Now they were circling the inner,
Cylinders.
Okay. Cylinder. And what was seen that the ink, yeah, tipa in Hebrew, I don't know. So it was stretching, and after that was disappearing. You don't see anymore the ink. When you circling to the opposite direction, you start to see again the ink. At first very stretched, and after that concentrate. And they show, and they do after that one drop of ink after one drop of ink after one drop of ink, and you can circling, and the first one is disappearing after the second one, after the third one, after this. And when we're circling the opposite, you see the first appearing, the second, no, the last appearing, the second appearing. And you see like a trajectory of a particle in a, you know what is a chamber? There is a chamber of bubbles. A lot of time when you finding when you finding a particle, how do you find it? Because it makes in a chamber cell a direct trajectory of bubbles that are interacting with the particle. You don't see directly in CERN or in those places, you don't see directly the particle, but you see what he leaves on the way when he interacts. So he said, wow, he has a very imaginative and childish mind in this. He said, maybe that's our particles. Particles are not real particles.
I understand.
But it's an appearance of something that comes out of the hollow movement, one by one by one by one, and we look at them as if it is a continuous trajectory of something, and we call it particles.
Right, but we still don't know what's something.
But really, it's something that dissolves and like foldment and unfoldment. It's like this. It's a movement of dissolve and organ, like this. And I liked it very much. I don't know if it's true or not, but it seems to me outstandingly. That out of nothing, that is filled with infinite energy that we cannot catch, because I told you that we cannot measure the energy of vacuum state, but mathematics tells us that there is infinite energy. Only mathematical manipulations take it out in order that we can make calculations. Very sophisticated mathematical manipulations. That's a picture.
Понятно. But it's still, it's a metaphor, mainly, right?
Yeah, it's metaphors.
So it's metaphors.
Bohm believed a lot in metaphors.
And the regular, like Copenhagen interpretation, they say that its probability is waving.
No, they say you cannot say anything about what is going on. You only can calculate probabilities that something will happen, but you cannot say anything about what happens.
Because the probability from a common sense of mind could not wave. Something like that.
No, there are people that talk about probabilities field or wave. There are people, but they are not referring to it realistically. They are saying it's only for imagining. It's not what happens. What happens, we don't know. We don't know, and we will not ever know. It's a black box.
Okay, I got it.